Question 33. Phenylethanone can be prepared by the reaction between ethanol chloride, CH3COCl, and benzene, C6H6, and it forms this chemical, phenylethanone. In preparation with an excess of benzene, the mass of ethanol chloride, Mr 78.5, was 5.7 times 10 to the minus 2 kilograms. So I've got the mass, it's in kilograms, but I can easily convert that into grams by multiplying by 1,000. So and I've got the MR, so I can work out number of moles of benzene, and therefore I can work out the number of moles of phenylethanone, which will be the same, 62% yield. I can work out the mass. Okay, so for ethanol chloride, moles is mass divided by MR, so the mass is, the moles equals, the mass is 0.057 kilograms, so because it's 5.7 times 10 to the minus 2, multiply that by 1,000 to get kilograms into grams, multiply by 1,000, 57 grams. So I've got 57 grams of ethanol chloride, Mr 78.5. So number of moles is mass divided by Mr, 57 divided by 78.5 is 0.726 moles. I've got 0.726 moles of ethanol chloride. That will react with 0.726 moles of benzene and make 0.726 moles of phenylethanone and make 0.726 moles of hydrogen chloride. But it's the phenylethanone that I want to concern myself with. So I've got the number of moles of this. So let's say that we've got 62% of this. 62% of this. Well, let's do the, I tell you what, let's do the grams first. So let's turn it into grams first. So number of moles is 0.726 moles of phenylethanone. I've got to work out the MR. Well, I've got 1, 2, 3, 4, 5, 6 carbons, 7, 8 carbons, so 8 12s. I've got a hydrogen on each of these corners here, not one on that one. I've got 1, 2, 3, 4, 5 carbons and 3 more, 5 hydrogens and 3 more. That is 8 hydrogens, so 8 ones and a 16. So my MR is 120 of my phenylethanone. So number of moles, 0.726, is mass divided by 120. Multiply the two numbers together. I've got 87.12 grams of phenylethanone. That's assuming 100% yield. 82.7. I've only got a 62% yield, so I multiply by 62 and divide by 100. I've got 54.01 grams B. 130 centimetres cubed of oxygen and 40 centimetre cubes of nitrogen at 298 Kelvin and 100 kilopascal pressure were placed into an evacuated flask. Okay. And I have therefore got what is the pressure of the gas mixture. I've got pressure, I've got volume. I've not got gas constant, interestingly enough. They usually give me the gas constant, but they haven't done in this case, which is very, very rare. But I'm going to have to use PV equals nRT. My total volume of gas is 170 centimetre cubed. I need to get that into metre cubed. I've got it in Kelvin, that's correct. I need to get this into Pascal by multiplying by 1,000. Let's do spoilers then, let's see. So my pressure is 100 kilopascals. To get it down into a smaller unit of pascals, I'll multiply by 1,000, so I've got 100,000 pascals. My total volume, it doesn't matter that I've got a mixture of gases, the total volume of the gas, so for this system in here, I've got a total volume of 170 centimetres cubed. So I'm going to work out the total number of moles of gas, oxygen and nitrogen combined, 100 centimetre cubed. To get that into meters cubed, I have to get it into decimetre cubed first by dividing by 1,000. So I'm going from a small unit into a larger unit, centimetre cubed into decimetre cubed. Then to go up into metre cubed again, to go up again into a larger unit, I divide by 1,000 again. So 170 centimetre cubed divided by 1,000, 0.170. Divide by 1,000 again, 0.00170 meters cubed. My temperature already in kelvins, that's fine. Pressure times volume equals nRT. 100,000 is my pressure in pascals. Multiplied by the volume, 0.00170 meters cubed, is n number of moles of combined oxygen and nitrogen gas. I'm not given the gas constant, but I'm given it earlier. on an earlier question, so I can easily look that up. 8.31 multiplied by 298, which is my pressure. I'd always multiply these out first and then multiply these out first, and these two multiplied together equals 17. These two multiplied out together equals 2476.38. Divide the 17 by the 2476.38. The combined number of moles of oxygen and nitrogen that I've got is 0.00686 moles. Now then, all I've done then is I've put these into a new flask of a new volume. The number of moles hasn't changed. I've put the oxygen and nitrogen together, that number of moles, in a new flask. So, and I've not changed the temperature, 298 Kelvin. I've just got a new volume, so I can just work everything out again. So pressure times volume equals nRT. My volume is 0.5 decimeter cubed. I need to get that into meter cubed by dividing by 1,000. So decimeter cubed up into meter cubed, I divide by 1,000. That's 0.0005. Pressure times volume equals nRT. Pressure, I need to find the pressure. So pressure I don't know. Volume 0.0005. I've just worked that out. N is the number of moles. That hasn't changed. All I've done is just change the size of the flask. So the number of moles I've worked out originally, 0.00686. Gas constant hasn't changed. Temperature hasn't changed. Let's multiply all those out. 16.99. Important to multiply them all out first on your calculator, then you're less likely to make a mistake. Pressure is 16.99 divided by 0.0005. 33976 pascals. All of these are in kilopascals, so to get pascals up into a larger unit value of kilopascals, I have to divide by 1,000, 33.976. 33.976 kilopascals. The closest one to that is 34 kilopascals. Two significant figures. My answer is C.